Lesson 16.1 Solving Trigonometric Equations continues. In this video, we will solve a trigonometric equation of quadratic form over the set of all real numbers. How do you keep a fool in suspense? I'll tell you at the end of the video. Solve each trigonometric equation over the set of all real numbers. So in a problem like this, tangent x or 3 tangent squared x minus 3 equals 0, we want to first use a little substitution to make the problem more simplified. So we're going to say z is equal to tan of x. So now I can replace tan of x with z. So we have 3 z squared minus equals 0. So now we can go ahead and solve this like we've done many a times. We're going to add 3. 3z squared is equal to 3. We're going to divide by 3. So z squared is equal to 1. And then we take the square root of both sides so that we get z equals plus or minus 1. At this point, we can go back and substitute tan x back in. So now we just need to tell when tangent is equal to 1 and when tangent equals negative 1. So that means x equals, tangent's positive in quadrant 1, so pi over 4. And tangent's also positive in quadrant 3, so that's 5 pi over 4. So remember that tangent is 1 when we're talking about the square root of 2 over 2 divided by the square root of 2 over 2. So then for when it's negative, that's going to be in quadrants 2, so that's going to be 3 pi over 4, and in quadrant 4, so that's 7 pi over 4. Now it says for the set of all real numbers, which means that we're talking about all values of all trig values that come out to this. So that means we also have to add the period in. And if you remember, we've talked about before, the period for tangent is just pi. So we're going to do pi in plus pi n to each of these. Where for all, not far. So for all integer values of n. So we're just looking for all the periods, right? It can be anything within the unit circle, and then beyond the unit circle, multiple rotations following the period. All right. So that's how we solve a quadratic using trig, or trigonometric equation of quadratic form. So what I'd like you to do is try number 4 right now, and then you can unpause and check to see how it goes. Okay, so z equals sine of x is what we're going to do to start, right? That way we get a simple quadratic function that we've solved several times this year. And so now we have 2z squared plus 3z plus 1 equals 0. So we're going to factor it. That means we're looking at two things that multiply to 2 times 1, which is 2, and add to the bottom, which is 3. And so we get 2 times 1 is 2, and you add them, you get 3. So we plug those in, we get z plus 2 times z plus 1, but we have to remember that 2 is out in front, so we need to divide each of those by 2. Once we've done that, we have z plus 1 equals 0. We have 2z plus 1 equals 0. Remember, you do bottoms up, so 2 goes in front of the z. You solve each of those to get z equals 1 or z equals, I made a mistake. We'll catch that right now. So z equals -1, which is going to change this answer to 3 pi over 2. Quick, easy fix there. Okay, so z equals -1, and sine of x equals -1 then. And so I showed you on the unit circle that sine of x is 1 at the top, so if we shift to the bottom of the unit circle, which is 3 pi over 2, that's when sine of x equals -1. Looking at the -1/2, made the same mistake there. Okay, so let's just jump to the unit circle real quick. So -1/2 is here and here. So here's my -1/2 here and here. So we're talking 7 pi over 6 and 11 pi over 6. So let's go back and adjust that. So 7 pi over 6, and we got to get rid of this 5 and put 11 pi over 6. Helps if you get the numbers correct. So that's how we find those answers, right? And then don't forget, we always add, and I'm missing part of what I add. We always add 2 pi in to each of the answers, because we're talking about for a set of all real numbers. There's no bounds for these, so that means that we just do the generalized answer, which means that it's for all integer values of n. And that's how we solve trigonometric equations in quadratic form over the set of all real numbers. Back to the question at the beginning. How do you keep a fool in suspense? I'll let you know in the next video.